Hi everyone. What we have here is a crank mechanism based on a 4-bar linkage type system, and it consists of the crank lever, a connecting rod that goes to the lever itself that we're actuating. And kind of the neat thing about these, right, is when you rotate the crank, you can see that the lever, this one here, is swinging in an arc. And you might say, well, what good is that? But there are applications where you would need either that arc or positioning issues. For instance, at this point of the 360 degrees of my crank, the position of the lever on this point is always going to be there. And inversely, when you go 360, 180, it comes all the way over to this point. So you have repeatability in a design like this. And one challenge that pops into my mind is what if there was a button on the competition table that you had to press repeatedly to garner X amount of points? Well, this would be a wonderful mechanism to do that, because once you position it, the location of that lever arm is going to consistently reach that point. So it's kind of a fun setup. It's pretty amazing how rotational motion, we can transfer that into positional, in this case radial, right? It's pivoting from this point here, constant. We also can attain linear also, right? If this pivot point right here was what they call a Scottish yoke, so it would be a slot rather than a fixed pivot. As this rotated, we could actually convert this motion into linear. So that's kind of cool too with just this apparatus. Um, Again, pretty fun how rotational can turn into linear and radial pretty easily. It's real common in mechanics. They do use pneumatics and hydraulics. Pneumatics would use a pressurized air cylinder to achieve like a linear motion. And hydraulics is oil pressure within a cylinder, sealed cylinder, that can produce linear. But it's pretty crazy in your everyday life how much we rely on just rotational motion to actuate something. Even if it's based on, rather than a perfect 360 degrees, it can be cycled also. That's something that, depending on how many degrees within the 360 you're actuating the crank, that would be determined by a thing they call machine timing. It's where in that 360 degrees that you're using to provide motion. But anyhow, let's quickly look at the construction of it, because there's some fun features in here. Um, for instance, in order to alleviate any cantilevering here, I have my main bracketry, which is this section right here mounted to my base. But I felt the need to support on two sides of the shaft to alleviate that, even though I'm using bearings in here along with an E-clip. And bearings, they have a lot of, um, they can absorb a lot of radial force. So that was the reason I chose those. But anyhow, you can see that I just bent up another piece of the aluminum in order to give me that little bit of an offset. And I did it in two locations. You can see even on the crank side right here, just to act as a support. And that's as easy as just taking a piece of the sheet steel, shearing it up, and bending it. I believe I did a 45 here and up to parallel with my other bracket right here. So pretty easy construction. The shafts themselves, in order to retain my lever, what I did was I turned a piece of the Delrin down to a 1/4 inch to fit the ID of the bearings, and then just used an E-clip. So essentially, I have a large diameter on one end of my shaft, turned down to a 1/4 inch that fits through not only my lever but the two bearings, and then the E-clip groove on the end. And I did that in 2 locations actually, one here and one here. So and then right inside right here, if you can see where my hand is, this is actually just a disc or a cylinder that's acting as a support to maintain the separation of the bearings as they are, and it makes that shaft assembly all one, retained by the E-clip. And again, it's the same process here, different thicknesses of course, because depending on where all this ends up being. So these two here would be similar. And the drive is just an aluminum shaft with a thread in the end, and this countersunk screw on here, because I found I had an issue with this lever right here, this point passing by the head of the screw. So I ended up using a flathead screw so that I was down below the face of this washer, or retaining washer, and that thread goes right into the aluminum shaft that goes through the 2 bearings and then into my crank assembly, my hand assembly here. A flat on the shaft to accept the 2 set screws to keep this from being able to just slip, and again the spacer to maintain parallelism on my bearing plates here. And just played around and did the same essentially process here as I did here, but I didn't really need the flatheads on these, so I just left them as the standard screw. So that's that there. So that's a pretty fun device, pretty simple. Again, something like this is great for repeatability. If you have your motor attached to this and it's just spinning, that lever arm right here, that throw, that radius is going to be consistent on the entire arc that it's swinging. And all these can be changed. This motion can be changed by just doing the math as to how long these particular are in relationship to each other. So like this lever arm right here, if you pictured a disc attached to the center of what I would call the input shaft right there, if this point were to be moved to a different radius from the center, it would give you a different dynamic in the throw. So you can play with that a lot too. And that's as simple as doing a quick prototype with some even cardboard. Just stick the pin of a rivet through the cardboard, 2 pieces, 3 pieces, 4, make yourself a 4-bar link, and see where that radius would be to achieve the distance of throw. That's, I guess, the technical term that I always used in machine building was the distance that we'll say from 0 degrees to a point here would represent what they call the throw of that radius that's going to be from the center line of this to this pivot point right here. So it's fun to play with that and see what you can achieve. So hopefully that generates a little bit of curiosity and questions, and maybe it even solves a couple of issues. All right, hopefully that helps.